Hello and welcome to the science class. My name is Teacher John. I'm going to take you through Science Primary 5, Term 2. Today we are going to look at heat energy. And heat is a form of energy that increases the temperature of an object. Heat is a form of energy that increases the temperature of an object. And we said energy is the ability to do work. Then we look at types of sources of heat. We have two types of sources of heat. We have natural sources of heat and artificial sources of heat. Natural sources of heat are sources of heat that are provided by nature. For example, we have the sun. And we are saying the sun is the main natural source of heat and light. We also have food. It's a natural source of heat. We have friction and erupting volcano. Those are examples of natural sources of heat. We have the sun, food, friction, and erupting volcano. Then we look at artificial sources of heat. These are sources of heat made by people. These are sources of heat made by people. For example, we have candles, lamps, and light bulbs. Those are examples of artificial sources of heat. Why do we call them artificial sources of heat? They are sources of heat that are made by people. Let's look at uses of heat to people. One, people use heat for ironing clothes, for drying harvested food, drying wet clothes. When you wash clothes, we hang them and they are dried by heat from the sun. Then heat is used for cooking food. It helps in rain formation, especially sun heat or heat from the sun. It heats the water in the water body, then the water evaporates in form of water vapor. Then that water vapor condenses to form nimbus clouds, and those nimbus clouds melt to form rain. So heat helps in rain formation. Number 5, heat is used for warming our bodies. That's why people sit under the sun, especially in the morning, to warm themselves. Heat helps in warming our bodies. That's how heat is important to human beings. Ironing clothes, drying harvested food, drying wet clothes, cooking food, helping rain formation, then for warming our bodies. Let's look at effects of heat on matter. When heat comes into contact or near matter, what is the effect? 1, heat makes matter to expand. Heat makes matter to expand. When you heat matter, it expands. Number 2, heat changes the color of matter. Heat changes the color of matter. Number 3, heat changes the state of matter. Heat changes the state of matter. For example, matter can change from one state to another. Heat can make matter to change from solid to liquid, and from liquid to gases, and from solids to gases. All that is because of heat. So it makes matter to change its state. That's why we say heat changes the state of matter. Then lastly, heat increases the temperature of an object. Heat can make the temperature of an object to increase. That's why if you put something under the sun, especially a metallic object, and you touch it, you find that it is hot. That means that its temperature has increased. So heat increases the temperature of matter. There are some questions which I want us to go through. Number 1, why are gaps left between rails? When railway lines are being constructed, we have what we call rails. Rails are metallic objects that are joined to form railway lines. So there's a difference between a railway line and a rail. A rail is just a metal that is joined to form a railway line. So when a railway line is being constructed, gaps are left between rails. Why are they left between rails? to leave room for expansion during hot days. To leave room for expansion during hot days to avoid accidents. Then number 2, why are telephone wires loosely fixed between poles? Telephone wires are loosely fixed between poles to leave room for contraction during cold days. So during cold days, contraction takes place. So when electric wires are being fixed between poles, they are fixed loosely. They are fixed when they are sagging, such that when it is cold and contraction takes place, they don't break. That's why we are saying it leaves room for contraction during cold days. And B, something to note. On a cold day, electric wires contract and become short and tight. On a cold day, electric wires they contract and become short and tight. Now, to contract, when they contract, it simply means that they reduce in length. And when they reduce in length, they become short and tight. Then, on a hot day, these electric wires will expand and become long and loose. So, its length increase when it is hot because of expansion. Question number 3. Why do electric wires become short on cold days? Due to contraction. That's why they become short, then and tight. Then, why do electric wires become loose and long on a hot day? So on a hot day, these electric wires become loose and long. Reason, it is due to expansion. Alright, we've said electric wires become long and loose on a hot day because of expansion. So meaning that when these electric wires are exposed to heat, they expand and they become long and loose. Then when they're exposed to coldness, they contract and become short and tight. So that is it. Then number 5, what happens to electric wires on the following days? On cold days, what happens to electric wires on cold days? They contract and become tight. Then what happens to them on a hot day? They expand and become loose and long. So that's what happens to electric wires during hot days and during cold days. Next, you look at why space is left in soda bottles during packaging. When when soda is being packaged, or when they are packing soda in bottles, space is left. They don't fill soda up to the brim. They leave some space, the way you can see on this diagram. So space is left when they are packing soda in bottles. Reason? There are 2 reasons why that space is left. One is to leave room for expansion. Now, what you need to know is that when liquids are under very, very low temperature, when liquids reach -4 degrees, when liquids reach -4 degrees Celsius, they expand. It is funny, but it is true. So when liquids reach -4 degrees Celsius, they expand. And that's the reason why that space is left, to leave room for expansion. I've said when liquids go below 4 degrees Celsius, they expand. So when they are packing soda in bottles, they leave that space for expansion. Because when you put a bottle of soda in a fridge or in a freezer and that soda goes below 4 degrees, that soda will expand. And when it expands, it will need more space. That's why that space is left. Then another reason is to leave room for increase in volume. During freezing. That means that when liquids are frozen, their volume increase. When liquids are frozen, their volume increase. And that means that they need more space. So when you are packing soda in bottles, that space must be left, because these soda bottles are put in freezers. And when they are put in freezers, they freeze. And when they freeze, it means that their volume will increase. And when volume increases, they will need space. So if that space is not left, they will break or crack. So that's why space is left in soda bottles, or that's why space is left in soft drinks. They don't fill them up to the brim, to leave room for increasing volume during freezing, then to leave room for expansion. I've told you that when liquids go below 4 degrees Celsius, they expand. And when they expand, it means they need more space. So that space must be left. Number 7, why is carbon dioxide put in soda bottles? Why is carbon dioxide put in soda bottles or soft drinks? To preserve soda. So carbon dioxide is put in soda bottles so that it can preserve soda. So that it can preserve soda. As simple as that. So we use carbon dioxide to preserve food, including soft drinks like soda, including even beer. We put there carbon dioxide to preserve it. Then we look at changes of states of matter. Remember I told you we have discussed effects of heat on matter, and we have said heat makes matter to change its state. Changing state means these objects change from one state to another. We have 3 major states of matter. We have solid state, liquid state, and gaseous state. So that means that when you heat can make the solids to change to gases. Heat can make solids to change to gases. Heat can make solids to change to gases. So that's what we are saying. Heat can change a state of matter. That's one of the effects of heat on matter. Now, I want us to look at the changes of states of matter. We have gaseous state, liquid state, and solid state. Now, we have process A. Process A, solids change to gases. When solids change to gases directly, that process is called sublimation. That process is called sublimation. So, sublimation is the process by which solids change to gases directly. Or you can say sublimation is the direct change of solids to gases. Part B, we have gases changing to solids. Gases changing to solids. When gases change to solids, that method or that process is called deposition. That process is called deposition. Therefore, deposition is the process by which gases change to solids directly. Deposition is the process by which gases change to solids directly. We have part C on the diagram. Part C, liquids are changing to gases. Liquids are changing to gases. And when liquids change to gases, that process is called evaporation. That process is called evaporation. That means that evaporation is the process by which liquids change to gases. Evaporation is the process by which liquids change to gases. Part D, gases changing to liquids directly. When gases change to liquids directly, that process is called condensation. So, condensation is the process by which gases change to liquids directly. Condensation is the process by which gases change to liquids directly. Then we have part E. Part E, liquids are changing to solids. Liquids are changing to solids. And when liquids change to solids, that method or that process is called freezing. That process is called freezing or solidification. Then So that means that freezing is the process by which water changes to, no, freezing is the process by which water changes to ice. Freezing is the process by which water changes to ice. Then we have what we call solidification. Solidification is the process by which liquids change to solids. When liquids change to solids, the process is solidification. When water changes to ice, the process is called freezing. Then we have part F. Solids change into liquids. When solids change to liquids, that process is called melting. So melting is the process by which solids change to liquids. Now, let's look at this. Sublimation. What is sublimation? Sublimation is the direct change of solids to gases. Sublimation is the direct change of solids to gases. When solids change to gases directly, that process is called sublimation. That process is called sublimation. Substances that can sublime. Substances that sublime. One, we have what we call iodine crystals. Iodine crystals can change from solids to gases directly. Then we have what we call solid carbon dioxide. Solid carbon dioxide. Solid carbon dioxide can change from solids to gases directly. Then we have what we call mothballs. Mothballs. Mothballs can change from solids to gases directly. So, substances which sublime are called sublimates. So, sublimates are substances that can change from solids to gases directly. Next, we look at deposition. Deposition is the direct change of gases to solids. Deposition is the direct change of gases to solids. Then we have evaporation. Evaporation is the process by which liquids change to gases. Evaporation is the process by which liquids change to gases. Then we have what we call freezing. No, condensation. Condensation is the process by which gases change to liquids. Condensation is the process by which gases change to liquids. Then we have what we call freezing. Freezing is the process by which water changes to ice. Freezing is the process by which water changes to ice. Solidification. Solidification. Solidification is the process by which solids change. No. Solidification is the process by which liquids change to solids. Is the process by which solid liquids change to solids. Solidification is the process by which liquids change to solids. So there's a difference between solidification and freezing. We said freezing is the process by which water changes to ice. Process by which water changes to ice. That is freezing. Then solidification is the process by which liquids change to solids. For example, you may have wax. Wax can melt. They become liquid. So if you have wax which is liquid and you leave that wax to solidify, to change into solid, they have not frozen, but they have solidified. So they have changed from being liquid into solid without freezing. But if you get water and you put water in a freezer, then that water changes to ice. That process is called freezing. As simple as that. Then we have what we call melting. We have what we call melting. Melting. And melting is a process by which solids change to liquids. Melting is a process by which solids change to liquids. Melting is the process by which solids change to liquids, or the process by which ice changes to water is the process by which melting is the process by which ice changes to water. So when ice changes to water, it's a process called melting. When solids change to liquids, the process is called melting. As simple as that. Now, next we look at effects of heat. Effects of heat on liquids. 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 1. Liquids expand when heated. Liquids expand when heated. Liquids expand when heated. Then liquids evaporate. Liquids evaporate. When you heat liquids, they evaporate. That's the effect. Then look at effects of freezing on liquids. Effects of freezing on liquids. When liquids are frozen, what happens? Effects. Effects of freezing. Effects of freezing on liquids. Effects of freezing on liquids. When liquids are frozen, 1, they increase in volume. Liquids increase in volume. Liquids increase in volume when frozen. When frozen. When you freeze liquid, their volume increase. And that's the reason why space is left in soda bottles during packaging, to leave room for increase in volume during freezing. So when you freeze liquids, their volume increase. Then liquids reduce in density. Their density reduce. Liquids reduce their density. Liquids reduce their density. Liquids reduce their density when frozen. When you freeze liquids, their density reduces. And that's the reason why ice floats on water. Because the density reduces. Once a liquid is frozen, the density reduces, but the volume increases. Then the mass of liquids remain the same. The mass of liquids remain the same. The mass does not change. When you freeze liquids, mass remains the same. When liquids are frozen, their mass remains the same. It does not change, it remains the same. Their mass remains the same. It doesn't change. As simple as that. Then we look at the effects of heat on gases. When gases are heated, they expand, NV. When gases are heated, they expand. They expand. And when gases are cooled, they contract. They contract. So when you expand, when you heat gases, they expand. When you cool them, they contract. So that's the end of our lesson. Please answer the activities about what we have learned. When we meet in the next lesson, we shall look at what we call temperature. In our next lesson. May God bless you and thank you for listening to me.